Let me introduce you to our speakers, Mr. Nirmalya and Mr. Shrinivas. Shrinivas is a principal consultant with C-Zone and has an industry experience of over 17 years. He is a Scrum and XP expert, and he understands how crucial software testing is and appreciates the role of testing in software industry. Nirmalya is an independent consultant having experience of over 20 years and specializes in server-side programming. He thinks testers and developers should always be part of the same team. He is always interested in creating uncommon software solutions using uncommon platforms and original approaches. So may I call upon Mr. Nirmalya and Mr. Shrinivas to please deliver their talk.
Good morning. My this talk, I got to know of this project, which basically is a product development, and essentially this whole talk is a case study, and I got to know of it as in the capacity of a consultant. So in a little second hand, Nirmalya here, who I've been friends with for 12 years, was the principal architect for this, and he played a very critical role in getting this product out, the right product out, the right quality, etc., because he did pay attention to it. Then, and this is a very unusual application. Most of us don't get an opportunity to work on an application like this. So we will get to know of it. And I also have here a member of the same team. Shiv, could you please make this known? His name is Shiv Kumar. He was a tester on the team. He's here to answer questions later on and so on. We only got him involved in the later stages of our presentation, preparing the presentation. So basically, massively, multiplayer online gaming is about many people who are playing a game online and together at the same time. So this could be like tens of thousands of people playing the game. We will also show you how, a little snapshot of what the game is. This essentially is a client-server application, but both the client and the server are handcrafted. They're not the typical Oracle versus Power Builder or Visual Basic sort of client server. Both the client and the server had to be built, pretty much from scratch. Okay, so now over to the client.
Thanks, Sri. Am I audible?
Yeah, you should worry about it.
Hello?
Is he audible?
Okay, before I begin, just a small clarification. I feel a bit a square peg in a round hole here because you guys are mostly from the QA background. I am not. So I'm not familiar with some of the terminologies or the way you understand QA. I happen to be from the development side, but I believe that QA is a very important part of software development, delivery, and predictability. And I also believe that QA should work hand in glove with the dev team from the very inception of the project. And that's what I try to bring in whichever freelance assignments that I do. At this point in time, I'm doing 2 assignments. One is with the telecom industry, and other is with the online gaming industry. In both these industries, server plays a very important role, and the most important aspect of the server is it has to be low latency, high throughput. So that we will see how that actually affects the server development.
Sorry, I didn't get to use the mic.
It's not working. That's not working. Okay. So we will see during the presentation how this particular aspect, which is server has to be low latency, high throughput, affects not only the design of the software, but the QA process approach and tools as well. I'll just give you a quick background of this particular software. It was the requirement was given by a large company who are very successful in lottery, and they want to come into online poker. How many of you are aware of the online poker? So it's a very, very interesting work. I don't know much about it. I don't know very well. But it's a very interesting work because the whole industry runs on the fact that there are about team very top level poker players across the world. And if you come on in the industry as just yet another poker provider, then you have two jobs to do. One, you have to somehow lure this 50 to 70 odd guys to your site by giving them some socks maybe. If you play 10 games, then we'll give you some dollars free or something like that. And second, this is the most important, they can make or break your business simply by word of mouth. If you come to your site, play a few tournaments, and then just simply send a mail across saying, don't go to nirmalya.com, it's a tad slow. Then the next day they actually see 30% reduction of the visits to your games. So as important. It's very interesting. It's a very different world. I didn't know about it when I came in, and since then I find it very, very interesting. And their concept of speed and correctness and all that stuff are very different. I'm not going into the design part of it, but just wanted to tell you that gaming world is very different. When you play games, multiplayer online games on various websites and using various tools, please understand there's a huge server-side software working in the background. And those servers are not in standard JTE world. Those servers are very different. That's not only we have to make some technology choices. Usually in the gaming world, the server is Java. In this particular case, the client was C++, and after I left, there was an attempt to make the client available on browser as well. It was a typical Linux MySQL, and we used RabbitMQ, and we were also one of the first users, to my little knowledge, in Pune, to use NoSQL databases for horizontal scaling. And we used a very interesting piece of software called vodQA, which was brought about by a bunch of engineers in a company, erstwhile Sun Microsystems, which is now Oracle Corporation. These guys got together and wanted to build a framework for MMOG, massively multiplayer online game kind of software. Just so happened, after they bought it over, Oracle decided to disown it, and now Network is in source storage. Still survives, but I think it has been forked many times over, and one or more people have taken the code and calling it really other kinds of software. The basic DNA of Network was that from ground software is built to be no latency, high throughput, network-based software. So use Network. This is a overall picture. You have something on a player portal where you come in and you register yourself and say, I'm so and to play poker. This is my country, this is the currency I want to transact in, and stuff like that. Of course, you have a database. I'm not sure horizontal in-memory database part here, just to keep the clutter less. And you have game servers, basically a number of game servers in the deployment. Tournament servers, a number of them. They interact to something called a lobby. I mean, explain to you what lobby is through some pictures maybe. And the whole interaction of RabbitMQ. Those of you who have used Rabbit kind of software, you know that the asynchronous is built in. And the moment I hear someone from TIPCO here, so he or she will probably know what I mean. Everything is asynchronous in the server-side software. Predictability is a very, very difficult thing to do. Everything is asynchronous. When you make a call, you don't know whether you will get a response at all. And if you do it within a stipulated time, and by the time it comes back to you, you will still find the response to your call is wrong. So the testing is very important here. Next one. Okay, this is a screenshot of something on a login for poker. So it's like you log in. Side and then you take it to something called a login. So it's like this. You come in here. Let's assume that the poker is being played across various tables. So when you come into this hall, you are in the login, and you want to have a snapshot to find out who are playing on which table, what is the current state of the table, how much is the red money, as in how much money you are going to win on the table, and then you decide whether you join the game, or you simply just want to remain and watch it. Okay? So remember that the moment you have come into this hall, you are in the server. So So you may not be playing a game, but you're still creating load on the server, number one. And number two, you must be given events of happening, what's happening on every table around this particular hall. So it's like you come in and you see a huge screen probably happening here, which keeps on telling you what's happening on which table. And there will be 20, 30, 100, 150, 500 tables. So it's like this. So you have to find out from this particular screen. These are the table names, these are the sticks, and what the players and stuff like that. Just to give you a feel of how does the software work. Next one. This is like your joiner table. Okay. So there are 10 pairs, and you are going to be one of them. I think there is an indication which says that who are you? So it could be you, it could be you, and there are the other players. The tables, the cards are dealt with by the software, and this is a client side only. We built it using Visual C++. All the controls were handcrafted. And the most interesting part is this chat. Okay, so the chat is very interesting. When the ace poker players actually play the game, they also chat between themselves. Alright? And very interesting, there could be some business logic based on the chat. So I need to find out if you are passing on information to your friend who is diagonally opposite to you on the table, and you're trying to influence the outcome of the game. That has to be chat. It's an illegal thing. That's a gaming software. Next one. Just 2-minute video just to tell you how the client looks like when the game is being played. And please understand that all these 10 players who are connected to the server must know what's happening on the table immediately. So that I throw a card, that feedback from the client must reach the server. And the response must come to me as to what the server has decided to do based upon my move. And also 9 other players at the same time. So that's a requirement. Okay, so 9 other players, you cannot tell them, look, you have to wait for a few milliseconds more before I deal with the primary mover. You cannot say that. So that's a requirement of the server. Okay, just one there, this is the lobby. So when you come to the lobby, you actually can see all these tables. Okay, what sort of poker? Poker has many variations. I don't know if you can if you're interested. I've got some here, poker has 12 to 40 different versions of poker. And you know what the players, how much is the stake, and blah blah blah, and you can click there to find out who is playing. There are actually some tables which are only made for ace players. So server has to know that if Nirmalya is locked in, he is one of the top 10 guys, and he cannot be taken to any of the tables. He has to be given a very specific table, and others who want to join him also have to go through a filtering mechanism to know that he is skilled enough to play Nirmalya. So if Nirmalya finds that the guy who has joined him, challenged him on the table, is actually a neophyte and is going to lose in the first round itself, Nirmalya can go tomorrow and write at the poker block saying, don't go there, the level of players are bad. And I can actually lose business. So it's very important. Okay, so very quickly we'll go through so the server had to be robust, obviously, it's network ready, completely on TCP. We use UDP for messages, TCP for the overall class-level communication. Server has to remember the state. Because remember, it's network, it's on internet, so you can actually get disconnected at any point in time. Server still has to remember what happened in the last move, any point in time. It should be easy to interface with external systems. Database is one, and there are reporting mechanisms and all that. Obviously, highly threaded, I'm not going into that. 20,000 seems to be a very small number for many of you, maybe, but I have to qualify that by saying, the average time for response have gone between more than 1 second. 1 second. So if it is anything more than 1 second, your oversight will be considered dodgy. 2010 Christmas, the highest ever, biggest ever tournament ever known to have been played on the internet. We had not the software we will, but second biggest poker software in the world had 150,000 players playing poker games at the same time. So that's a kind of number to talk about. Like I said, you may actually walk into the hall, you may actually walk into the lobby, you may not play game at all, but you're still a player on the server. Servers, you increase servers load, server still has to tell you what's happening on each of the tables. And as the number of such walkers increases, obviously server has to do much more job. And this number is indeterminate. You cannot tell beforehand how many people are going to walk in. In fact, the more, the merrier. So, how do you test? Is the question. How do you test the predictability that for 20,000 guys walking into the lobby, server behaves fine. But the server is also going to behave as fine when the number of 20,000 becomes 80,000. Is the server really going to behave in the predictable manner? You have to test it. And of course, speed and order of message exchanges between server and client are of essence. The server is asynchronous. But the order in which messages reach the client has to be in a predefined order, because otherwise the client will be confused. So there is a big disadvantage. Okay, so randomness, you have to be random. It's a legal requirement. We have to prove every time that when the cards are being dealt, they actually follow a random number pattern. It has to be kept according to the levels, and you are actually legally prosecutable if it is found that your distributions were not rated out. And I'm not going through all the points here, probably a pretty short time, so I will spend a bit of time on these 3 points. Like I said before, we are joining just to watch others. So we had something called a watcher. Watcher is a person who is just simply standing on the side of the table. Not making any moves, not making any comments, not involved in chat. But everything happening on the table must also be reflected on his screen, and he may be 20,000 kilometers away. Okay, so this is just a watcher. Network connection, so player may drop at any point in time. Server must continue. So network may drop at any point in time. Network may come back in any point in time. It's not really a browser-based application, so there is no refresh cycle. It can come in any time, it can go in any point in time. Server must be charged. More interesting is that a player finds that the situation on the table is not really conducive to him, he may decide to sit out for that particular round and join in at an opportune moment. This whole thing is asynchronous. You have no control over when the particular player wants to sit out and join in. The game is continuing. Okay, so if you just think about the unpredictability of the user behavior here. Everything in real time. Just this point, game history has to be sort of safe for future purposes. 1, audit, 2, legal requirements. 3rd, and this is where the QA came in, is that we, as a number of rounds are being played across the table, we actually store all the rules of individual players. And we did it in such a way that we can actually feed that train of moves back into the server so that it can reproduce exactly what happened in a particular game. Am I making sense? So, all the moves of the player are being saved and trained in such a way that if you feed it back to the server will play as if human players exist. Okay? And retrace the path exactly as it happened. It was useful for the QA and it is a legal requirement. Next. So, how do you test a piece of software from the server side, of course, which is inherently asynchronous? So, it is not a request response. You don't send a request, get a response, put a check, and then say fine. It may happen, it may not happen, it may happen after some time, and even if it happens after some time, it may be right or wrong. You have to test and preferably in non-negative fashion. Performance is unknown, so I'm not going to that obviously it's necessary. Testers have to be very good proper players. Because she is one, I know that is one of you, few tournaments as well, and I don't know how many. I mean, it's usual to hear that a good tester is a good banking software guy or has been in the retail banking before and all that. But before I came to the gaming world, I never found that this was a requirement. Do you get over? I mean, timers. Timers is a very integral part of the server software because the server has to, even though the behavior of a particular player is predetermined, remember, asynchronous, he may take an action, he may not take an action, but the server cannot wait forever, right? The server has to create timers for itself. And remember, it is a myth, and I've seen that many times. People think that if I set up a timer for 3 seconds, the timer is going to be fired after 3 seconds. That is never guaranteed. Unless you are using something like an RDOS, which is like real-time OS systems, or real parallel system. I'm a little afraid to talk about parallel systems here. My friend Ravi has literally done a PhD on that program is sitting here. But other than those very specialized hardware software combination, please understand a timer is never guaranteed to be fired after the timer duration that you set it for. It makes the best case possible. It makes the best for. So if you say, look, I want a timer to be fired after 3 seconds, then the only guarantee is that it will not be fired before 3 seconds. But you can actually fire any time after 3 seconds, depending on the server load and the CPU level of business. Okay? So think about it, you being a guy who is actually trying to write a test case for a situation like this. That is the picture. Example. Okay, it's an asynchronous behavior. So this table, these are the players present. So let's say P2 plays. P2 plays a hand. And then at this point in time, while this guy plays, this guy takes his game. A message goes from client to server and comes back to this particular player, and it also goes to other 3 players at the same time. At this point in time, P3 decides that I'm going to sit out because the money on the table is high and I don't want to risk losing a chance now. So he may decide to sit out. Now what is the sitting out? Sitting out is that you be the server, you be on the table, you are actually on the game as far as server is concerned, but your status is different. You are actually sitting out of the particular table. Server will simply assume that you don't want to play your hand this time. He will bypass you. You will assume a default action on your part, which is kind of a business logic, and goes ahead. Okay? So now it goes to P4 because P3 has decided to stand and sit out. So what happens? Server allows P4 to take his turn, and then something happens in the game, going like a poker route. And it's a handover. We call it a handover because that's the end of. But then at this point in time, P1 deals a new hand. So the game is continuing. At this point in time, while the new game has just begun, new hands has just begun, P3, who has been out of the game so far, has decided to join in. So there are 2 distinct threads running here. One thread is controlling the game flow on the table. Whose turn is next? Other one is that this player who had gone out earlier has decided to come in. There are 2 different things happening at the same time. Obviously, there's a logging thing, obviously, there's a race exclamation possibility and stuff like that. But the QA has to prove that when P3 wanted to come back to the table, he actually was allowed to do it, even while the game was on. So there are 2 concurrent threads running here. You have to write a test case to prove that it happens predictably under all conditions. So that's a challenge. I mean, obviously, either I have bored all of you or started with the information that I gave you. So please ask me questions if you have any. So she was a QA guy, he actually found many bugs. So he has been nice enough to give me only a few of them. So Don't think the server was so good that only these few bugs are found. No, there are many bugs. They actually did. These are the sum of them. Once a player is disconnected, he should be able to log in. Remember, quickly, because it is possible that on the table the stake is so high, about $5,000, and the last call is yours, and you have a very high chance to win those $5,000. At that point in time, you are disconnected from the server because of internet and VSL. Right? So what are you going to do? You are going to frantically come back into the game. Right? Because you don't want to lose that money. At this point, server cannot say, sorry, load is too high, wait for 2 seconds. Not possible. If you do that, this guy, what he's going to do tomorrow, write this SMS saying, don't go to Nirmalya.com. They actually freeze you. Just when you're about to win $5,000, they have taken you out of the server. Okay? So disconnected players must be allowed to get in as soon as possible, especially if the stake on the table is very high. Negative balance for player, poker related, I'm not going to that. This is very interesting. Okay, so if I'm playing, what happens is I go to the table with a wallet with $100 and I say, look, I'm putting $20 here. And the game carries on, right? And suddenly the server fails to keep me connected. So what that means is that I must get that $20 back to my wallet. Right? And expectation is that it must happen immediately. So remember, in the lobby, I can actually find out how much do I have in my wallet. I came in with 100, it became 80, and just when I disconnected from the table, it should again become 100 immediately. Alright? So remember this. Rest, I think it's fine, and other part we are not worried about, but just to give you an idea. Yes, poker players don't prefer playing table games, not against table games. They actually come from tournaments. Because tournaments are high stake games. You win $5,000, $6,000, $10,000. Tournaments are a very different ballgame because there are points in time in the tournament when, let's say, matches are happening on 4 tables. You have one from this table. Matches are going on in the other 3 tables. Unless the winners are declared on those 3 tables, you cannot really play your next match. At this point in time, you are in the tournament, but you are not on any particular table. You are actually increasing the load, and you may actually be able to chat as well. So suddenly your player state changes. So the player, the user who has logged in, is a player, is a non-playing player, is a player again, is a non-playing player again. So this user status change through the whole tournament's lifetime is a QA nightmare. You have to prove it every time that yes, he is a non-player, yes, he is a player.
Oh, good question. Will you be talking about how to get the predictability into the system that comes to testing?
Yeah, I just my last slide. So, a few of the steps we took. The grade ones I'm not going into, even though the first one is very important. We actually modeled the whole game as a complete finite state machine. It is probably the best modeling technique for this sort of asynchronous systems. Those who are in the popular world will probably know XNN, and they use this concept called finite state machine. Most of the protocol analyzers use finite state machine. So we modeled the entire poker game as a finite state machine. It's extremely testable piece of component. I'm not going into that, but it was one of the design decisions we had to take to make the QA guys' lives easier, because they said we should be able to test 2 things separately. One is an A-B play according to the rules is one kind of testing. Other kind of testing is if 10,000 games are being played at the same time, then it is the predictability of the whole software in that tournament. So there are 2 things. To address the first one, we designed for finite state machine. We created event watchers. There's nothing new for most of you. We used JMX events. So the server was constantly editing event information from within the server to the JMX saying this level, that level, this layer, that layer. Okay. Log messages, I'm not going to that because log messages is very important. The systems guys are dealing with GBs or log files when the poker is deployed. So we have to make their lives easy. Next. This is a key thing, and that probably gives you an answer. And my last point here actually. we wrote bots, handcrafted Java programs who are actually poker players. So the entire poker intelligence was built into Java programs, and they were all configurable. How many can I run? How should they play? At what level of intelligence? And completely configurable. So it was easy for us to create a load of 20,000 simultaneous poker players of various intelligence levels by programming. You can never assume to have a 20,000 players load being created on the server by human players. It's not possible. Correct? And this was 3 years back, 2.5 years back. Cloud was just on the horizon really, so we didn't go into that. But these bots are the most important part. We had to take QA guys' help. In fact, some of the bots were written by the QA guys themselves, because remember, they are the poker players. Their poker knowledge was encapsulated in Java programs and then written by us, the dev team, in such a way that you can actually run 10 of them, 20 of them, 100 of them, thousands of them at any point in time. So, and then while running these bots, you could then go into the rear door of the server, keep getting events, and find out the predictability of the software. So this is the key thing. The point I'm trying to bring is that QA guys were very, very closely involved with us from the very beginning of the design. Yep, and that's last slide. JS console, I mean, I think those of who you are the Java world, you probably know the JS console. It's a Java core Java feature by which you can actually write a server in such a way that specific data elements from within the server can be emanated to a console, okay? And you can find out how the data is changing from time to time. It's a live thing. Okay? In fact, if you install JDK, JConsole is the console for JVM.
Can I interject? So for the testers and QA, the thing is the rest of the software you see here, player portal, game server, everything else, is so that the software can run, so that it can be used. But the JMX console and the bots are not there so that it can be delivered, because they're more or less there's a software written by developers so that testers can actually test, and you can satisfy all those legal requirements and so many other things. So they are made to test with special tools. So that's the reason they're there. And the rest of the software, the customer is going to play. But for this part, the customer is the tester. Tester is the customer.
I think I have just one more slide. So testability of the software, something that I'm sure most of the people here are conversant with. It's called the testability. It's a very important element in the server-side software. You have to be able to test it, right? Just building a feature is not enough. How do I allow the QA to test it is also a designer's problem, and QA's inputs are most important. Okay. So we would go Java-based robots, like I said, and key point is here. Testing cannot be an afterthought. It's a part of planning. So you have to involve QA guys from the beginning. Collaboration is very important, obviously. And this is what I think is the most important part. This usually don't happen because I happen to work with small startups and very technology-minded, very nimble companies. They don't mind doing it because they appreciate the fact that if you really put time at the beginning, it's going to pay dividends later. But what I want to share with my QA world friends here is that I think you should insist on your presence in the design discussion, in the initial requirements analysis discussion, and of course the testability assurance discussion from the very inception of a software project. Any question?
So basically, any online particular like thousands of people are playing it concurrently, right? So for such games, how did you identify the performance requirement of that particular software? Any specific criteria?
The peers who are poker players themselves actually gave us NFR requirements much before the poker game rules. Because poker game rules could be modified a bit depending on what you do. But NFRs were very, very clear. Two parameters especially, the latency, the time it takes for a given message to reach from server to the client, on an average was given to us. And the throughput, in an unit time, how many messages actually can you transport from server to the client. These two were the constant parameters we ensured that were recorded. Remember, latency, which is the time it takes for an average message to reach the client from the server. And the second is throughput. In a given time, how many messages can you transport from server to the client under certain load? 20,000 players load, 50,000 players load, 100,000 players. Does it answer your question?
You talking about replacing the players. So it's a kind of in real world you can't really have the people with 20,000 mindset. But here in the writing program you will just try one scenario to use the box, something like that. Where I'm coming from is I was testing something similar to an online auction. So there it was very difficult to simulate the actual auction. Because there are different people with different ways around and they have different mindsets when to withdraw the bill and when to revise the bill, something like that. So for us the challenge was to actually simulate the auction. Because whatever we tried to run or any other, it was like you put a specific time difference and put a bid and then there will be very specific scenarios there. But a real time auction would be completely different from that. So how do you, as the human intelligence, what do you kind of do?
Try and answer that. Sorry, I can. I'll try and answer that. It's a long-winded answer, really interesting question. Two things. One is that in the bots we actually built in intelligence levels, so it will play like a complete dojo or an S. So there are 3-4 intelligence levels in the bot logic that we wrote. So while running a bot, I could actually say something like Java minus CP blah 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 and intelligence level 3. So then what happens is that player will pick up that level of intelligence while playing the cards. So that is one. And the other thing was, please understand that while bots are playing on the server, it is not necessary that only bots will play. What we actually did was that on every table we put 9 bots and 1 human player. So the human player brings in his own intelligence to play against the bots to really see if the poker rules were properly followed. So the bots were that extra, gave us that extra advantage to actually create load on a particular table. So like Sheep could play with 9 very high level bots, but I can play with 9 very low level bots. And in both the cases, the rules had to be followed. So yeah, to answer your question, we actually put a lot of effort in writing the bots. And Srini raises a very good question that if your bots are Java programs which are complicated, how do you test the bots themselves? So that question was very, very important, and we kind of managed that through just code review, nothing else.
Let's take last question.
You mentioned about some randomness. You use some kind of algorithm. Since we have read somewhere that there is some pattern analysis that is being generated. So like, is there any specific algorithm that you guys use and which is legal requirement?
In the poker world, there are 2 or 3 hardware companies. You have to purchase their hardware because those are the only ones trusted by the poker community. And those hardware chips have to be, these are basically some USB kind of stuff these days. You have to put it on the server. And for every random number to be generated, you have to make a call. It's a C call, C programming call to that particular device and get the next random number. So that way we didn't have to deal with the proof of randomness. The hardware did it for us, and those hardware devices are certified by the poker community. So when you come up to the industry, you have to say our hardware device is from ABC Incorporated, Poker Community Trust.
Mr.